Okay, so today we're talking about oxidative phosphorylation, excuse me. So this is the last part of the uh, last part of cellular respiration. This is where we get our bang for the buck ATP, and this is going to show you why right here. I'm not going to go into the numbers of it, that's going to be tomorrow. But I just want to, so where are we in the cell? I want to go over that first so we know where we are. So here's, if this were, bigger line, if this were the cell, so we have the cytoplasm, right, of the cell. This is the cell membrane, and then right here we have our mitochondria, right? So I'm trying to draw cristae as good as I can. So we're going to have our inner matrix. I know this is a lot of repetition, but that's how you learn. Inner matrix, we have the inner membrane. We have our outer membrane. And then we have our inner membrane space, okay? So we're actually kind of like looking right here if we were, or right here if we were zoomed in here. So this is our outer mitochondrial membrane, inner mitochondrial membrane, some proteins in the inner mitochondrial membrane, and what's in the inner membrane space. So what happens is we have all this NADH and FADH2 coming out of the Krebs cycle and coming off of our glucose, or glycolysis, excuse me, and the link reaction. So we have all that coming off, and so those products, the NADH and the FADH2, these electron carriers, they're going to come to the proteins in the inner mitochondrial membrane. Because remember, the Krebs cycle is going to happen in this inner matrix, so it's going to go to these proteins and drop off their electrons, and the electrons are going to move through. And as the electrons move through, they're going to be drawn towards some oxygen. And the oxygen plus the 4 hydrogen ions plus some hydrogen ions are going to make some water. So 2H2O. So this is why we need to put oxygen back into the cellular respiration. Basically what's going to happen, this is just like in photosynthesis. The electrons flow through these proteins, which gives the energy for the protein to pump hydrogen ions. So now we have a high concentration of hydrogen ions in this inner membrane space below out here, and so they're going to want to flow out, and right here we have our dandy little friend ATP synthase, and this is where we're going to make our ATP. I hope that's spelled ATP. So right here. So basically, oxidative phosphorylation, without tracking numbers super tight, we're here in the inner mitochondrial membrane here. The electron carriers drop off their electrons, they go through the electron transport chain, pulled towards this oxygen molecule. That's going to make some water for us. And then as the electrons move through the proteins, hydrogen ions are moved through to create this high concentration of hydrogen ions. And the high concentration of hydrogen ions are going to move back out through ATP synthase, and the moving of the hydrogen ions through ATP synthase from high to low concentration is what's going to make us some ATP. And I hope that was helpful. I'm going to get into some numbers later. Hope that was helpful.